Teardown time. This is the Kindeep G4 LED. It's a replacement for a small halogen 12-volt bulb. They've listed it in Amazon here for about $1.70 per bulb. I bought a 10-pack. I've seen the exact same assembly under a different number of trade names. If you open up the plastic casing, you see a circuit board looking straight down. And of course, there's 6 LEDs on this side. There's 6 on the other side as well. Let's first take a look at one of the individual LEDs looking straight down. It's illuminated at a very low current, and you can see the LED itself is in the center, of course. The 2 little wires going off are, of course, the bond wires which connect the lead frame to the actual LED die. And then, of course, we have the phosphor, which is the yellow material, and then, of course, the carrier that holds it all together, the white item. Let's take one of these off the circuit board, and we're going to cross-section it here. And with this cross-section, I can then look straight down with a camera and see the structure as well. The item in the center that I circled is the actual LED die. And then, of course, you can see the phosphor with that sort of tub-like shape. I suspect the LED produces a fair amount of light going on the side here. Then it bounces upward. There's obviously some sort of optical geometry going on there in terms of its structure. The copper-like material, of course, is the lead frame. That's the actual connections back into the package to the circuit board. And there, of course, is the white material holding the actual item together. So that seems very typical of a surface mount LED construction. They always seem to have this construction with a sort of V shape to it. Let's see, zooming back out here, we have the inductor sitting in the center there. That's a strong indication that the component next to it must be a power supply. It's marked 1360, and if I search the web, I've come up with this Diodes incorporated part, which looks like a very close match. It looks like a boost regulator. And if we look at the application note schematic, there's a small resistor that's used to set the current that goes to the LEDs. The LED is running in series there with then the inductor in series with the LEDs. And that matches the exact topology of this circuit board. The only difference on this board is there's a full wave bridge rectifier on the other side, so you can feed it with AC. A lot of halogen bulb systems use a small AC transformer. Let's de-encapsulate this package and take a look at the controller die. Well, let's see here. This is the die identification 1360, so it matches the packaging number. That's not always the case. Sometimes the silicon die will have a different number than the vendor packages it into a number of parts. Looks like here there might be more of a 1-to-1 ratio. If we take a look at the entire silicon die looking straight down, we get this photograph here. Let me just spin it around and compose it with the actual schematic of the internal block diagram. They've actually exposed a whole bunch of details. You can see there's a couple of reference voltages going into some op amps. There's a structure there that looks like a sort of a circle or a fort. I suspect that might be the band gap reference. About half the die is probably a single transistor circled there. It's obviously a power function. You need to spread the current out, and that's not too unusual to see the power transistor dominating the entire silicon die. Okay, so here we have the scope probe sitting on the inductor. You can see the switching frequency quite high, 473 kilohertz with a 12 volt. If I reduce the voltage, you can see the frequency drops quite dramatically. In fact, if I go down to a single volt only, it goes down to 293 kilohertz. And if I come up a volt to about 13 volts, pulls up to about 585 kilohertz. So fairly significant frequency changes as the incoming voltage changes. So there we go. That's probably a pretty straightforward teardown. Not too many surprises, but it's always fun to take a look at the actual underlying technology, looking at some of the tub-like structures there as LEDs, and of course recognizing that even the simplest LED controller these days has hundreds of transistors on it and performs a surprisingly complex function.